Continuing the discussion on uncertainty, let's propagate the error through an addition-subtraction example. So, here is the formula for propagating the error or the uncertainty. Sometimes I use those interchangeably, even though I should use uncertainty instead. But what we do is we take the absolute uncertainty for the first measurement, we square it, we add that to the square of the absolute uncertainty for another measurement, the third, and so on for however many measurements we have, and then we take the square root of that, and then that will be the new propagated error. So let's do a quick example on this. Let's say that I took a pipette that is 25 milliliters, and the 25 milliliter pipette has a standard absolute error of 0.03 milliliters, and I've added that to a flask. And then I have a burette, and I'm going to add additional volume from the burette into the flask. I just made up this example to be simple. So the burette, initially we read it at 0.23 milliliters, and that has an error of 0.05 milliliters, plus or minus. And then we also have the measurement of the burette at the end, when we stopped adding to the flask, at 27.48 milliliters, and that has a standard uncertainty of 0.05 milliliters. Same uncertainty for the burette, slightly different uncertainty for the pipette, just some of them are, you'll have to look that up for each individual piece of glass. And often it's written on the glass. It'll say tolerance plus or minus and then whatever value it is. So we should first calculate the final volume that I've added to the flask. So I'm going to take 25, and I'm going to add my volume from the burette, and I'm going to subtract the initial volume from the burette so that I only have what I added. And I should get 52.25 milliliters. Now, this might explain why somebody would use a 25 milliliter pipette, because, well, I've added more than 50 milliliters and maybe I had a 50 milliliter burette. So this was just to make sure that I wouldn't overrun my burette. So that's a possible scenario. All right, so now I have this value, but I need to know the uncertainty in this. And it's not just as simple as adding up 0.03 to 0.05 and 0.05. Again, some of these volumes may be higher or lower than each other, and it will tend to cancel out a little bit. So we're going to use this formula to determine the propagated error. So let's see here. With our first measurement, we put in our absolute uncertainty. And we're going to add the uncertainty of the burette measurement for the 27 milliliters, which 0.05. We square that. And the other burette measurement, also 0.05. And then we'll take the square root of that whole thing. And if we do that, I've calculated that as 0.0768. But usually these get rounded off to just one significant figure. So 0.08. So when I write my final answer here, I should write it to the amount of error that I have. The error starts at this digit right here. So that's how many significant figures I have. Now you may notice that up here, I do have 4 sig figs. Down here, I'm maintaining that, but that might change based on how much error I have. If I added more steps to this, I might have been able to get this up to 0.1, and then that would change the number of significant figures in my actual answer, even if the rules say that I've got enough. And also, I might not always write this, but this really is 25.00, just because we're using a pipette, we're accurately using a pipette. So we're really considering the number of significant figures is really where the uncertainty is starting. So as soon as the uncertainty starts, the significant figures stop at that point. So 52.25 plus or minus 0.08 milliliters. That's my actual result, and that's the propagated error.